Morning everybody. So today let us continue with the second session, and in second session we are going to go ahead with the derivation of expression of radius energy and ionization energy for hydrogen and hydrogen-like atoms. So in today's class we will be going ahead to derive an expression for radius energy and ionization energies of hydrogen and hydrogen-like atoms. So when we come to the derivation, let us consider hydrogen atom. I am going to consider hydrogen atom having one electron. So considering hydrogen atom having one electron, one proton in the nucleus and one electron revolving around the nucleus. So this is represented in the figure. Let the charge on the nucleus be represented as Ze. But as it is hydrogen atom, Z is going to be 1, and for hydrogen like atoms, like for He plus, Li2 plus, Z can be 2 and 3. The electron with charge E, suppose here the electron with charge E is going to revolve around this nucleus. This is the nucleus which Ze, then this electron is going to revolve around this nucleus. If V is going to be the tangential velocity, let V be the tangential velocity, m is the mass of the electron, then according to the laws of classical mechanics, the centripetal force acting on the electron in hydrogen-like system. Here, centripetal force acting on the electron in hydrogen-like atoms is going to be Ze into E by R square. This centripetal force is going to pull the electron towards the nucleus. Centripetal force is going to pull the electron towards itself, whereas the centrifugal force acting on the electron is given by mv square by r. Centripetal force pulls the electron towards it, whereas centrifugal force acting on the electron is going to tend it away. So these are the two opposing forces that the electron is going to keep rotating or revolving in its orbit. So when the two forces are going to balance, that is the Coulombic force, centripetal force, which is going to be given as Ze square by R square, and that is equal to the centrifugal force, that is mv square by r. I am going to number this as equation 1. Now from this expression, V square will be given as Z square by mr. But we know according to the postulate, first postulate of the angular momentum is given as mvr is equal to integral multiple of nh by 2 pi. As we know from Bohr's postulate, mvr is equal to nh by 2 pi, and the expression V is given as nh by 2 pi mr. Squaring this equation 3, we will be getting the expression V square is equal to n square h square by 4 pi square m square r square. Next, what do I do is I am going to eliminate V square from equation 2 and 4. I am going to eliminate V square from equation 2 and 4. When I remove this, then the expression will be Ze square by mr will be equal to n square h square by 4 pi square m square r square, or Z square will be given as n square h square by 4 pi square mr. So this is equation 6, and according to equation 6, the radius r of the orbit will be given as r will be equal to, now getting the expression for r, that will be equal to r is equal to rn, that is n square h square by 4 pi square Z mv square. For hydrogen atom, Z is equal to 1. When I substitute Z is equal to 1 for hydrogen atom, the radius of nth orbit can be given as n square h square by 4 pi square m e square. Now for hydrogen-like atom or hydrogen atom in the ground state, the R1 will be given as R1 will be equal to A0, that is h square by 4 pi square m e square. This was all about in radius. Next, when we come to the derivation of the energy of nth orbit. Now, in case of nth orbit, I first want to consider the total energy E of the electron revolving in the nth orbit is equal to. Total energy is actually the sum of kinetic energy and potential energy. Kinetic energy is given as mv square by 2. Potential energy is going to be given as minus z square by Rn. Accordingly, total energy, which is sum of kinetic energy and potential energy, will be given as E is equal to 1 by v square minus z square by Rn. This is equation 10. I know from equation 2, mv square is equal to z e square by Rn, and number this as 11. Substituting the value of mv square in equation 10. Substituting the value of mv square in equation 10, I will be getting the equation as E is equal to z square by 2 Rn minus z square by Rn, which is equal to minus z e square by 2 Rn. This is equation 12. Now what do I do? Substituting the value of Rn. Next, what I am going to do is substituting the value of Rn from equation 7 in equation 12. We are going to get it as, we will be getting it as E is equal to minus z square by 2 into 4 pi square z m e square by n square h square. This is equation 13. So now the energy of the electron in nth orbit can be represented as En. Energy of the electron in nth orbit is represented as En, and this En will be given as, will be given as 2 pi square z square m e to the power of 4 by n square h square. For hydrogen, z is 1, then the ground state, n will be equal to 1 for hydrogen in the first state. So E1, first energy level, the energy of first energy level will be given as minus 13.6 electron volts. But for hydrogen like atoms, the energy will be given as, the energy of the nth orbit will be given as minus 13.6 electron volts into z square by n square. Coming to ionization energy. What is ionization energy? Ionization energy is the energy required to remove the electron completely from the lowest orbit. Energy required to remove the electron completely from the lowest orbit, that is n is equal to 1 to n is equal to infinity, where energy is 0. So ionization energy will be given as minus En is equal to 0, that is 13.6 electron volts into z square. So for hydrogen atom, z is 1, so ionization energy will be 13.6. But for helium, that is 2, ionization energy will be 54.4 electron volts. And for lithium, it will be Z will be 3. So when I substitute this as Z square, then it will be 122.4 electron volt. So the references here is going to be Puri, Sharma and Kalia, and Inorganic Chemistry by James E. Thank you.